All right. Look, good morning and welcome, everyone. My name's Shahana McKenzie from Bioenergy Australia. For those of you that don't know, Bioenergy Australia is the non-profit industry association seeking to drive the development of Australia's bioindustries. Now, this is going to be hard as people join me accepting them and speaking. We will manage it somehow. I'm just going to finish my intro and then I'll welcome everyone else. I'd like to thank Andrew Lang, Kelly Wickham and the Victorian Bioenergy Network for partnering with us on delivering this event. Andrew Lang is going to be operating as the moderator for today, and he'll be doing all of the Q&A at the end of the session. So in order to engage in questions or to be able to list questions, can you please pop them in the chat function of in the chat function over on the top right-hand side, you'll be able to see, and you can type in your question as the speakers are actually presenting. Andrew will be able to look at those questions throughout the presentations, and he will then be able to direct the questions to individuals for the Q&A at the end. In order to assist in limiting distractions and making sure that we have good bandwidth and those sorts of things, can anyone who is not presenting please have your video turned off and your microphone placed on mute? And that way we will be able to ensure that when people are speaking, they're not going to have any issues. Thank you so much. And at that point, I will hand over to Andrew. So Andrew, you unmute yourself.
Yes, thank you. Thank you, Shahana, and Lauren and the other members of the team at Bioenergy Australia. It's really good to be doing this webinar with Victorian Bioenergy Network. This is our first real event since reforming. And just to say a little bit about Victorian Bioenergy Network, we did it as an unincorporated body, and then went into recess for a little while. Kelly Wickham and Liz Hamilton in Victorian departments were managing it, and then we reformed. We're building up slowly, and it's an incredible time for bioenergy in the state. And so this is a call for new members, and at various times, I'll say that again, but there is my email and Daryl Sherger's email, and all we need is an email from you guys, and we will send you a membership application form. One of the things I've been doing is getting overseas until this year, obviously, and seeing just how bioenergy is developed around the world, and then relating it back to Victoria and how we can be doing basically all of the things. So in Finland, producing over 10, 12, 13% of our power. Sweden producing over 20% of our fuels. Many countries producing over 30% of our industry heat from biomass. And with the rising cost of gas and the rising cost of power at industrial or wholesale or even retail prices, it is now all coming to pass. Many people say that there is no silver bullet, but really bioenergy is the silver bullet from this point of view. Victoria is really well placed, and at the moment we've got these various things, including the Victorian Renewable Energy Target version 2 coming up, and a number of things that are in development. So at that point, it's time for me to move on to introduce the first speaker. Before I do that, for people who have just been signing in, if you can switch your video footage off, just to make sure that everyone's got as much bandwidth as possible, including me. Ray Davies is the first speaker. He's Economic Development Officer with Pyrenees Shire. He's been a pivotal person for rebuilding Victorian Bioenergy Network, and has been very important in getting some things happening in that shire and the region. Just to say it again, if people could keep their video footage or streaming turned off, just to maintain all of our bandwidth, please. So Ray, if I can hand it over to you, please.
Thanks, Andrew, and appreciate the introduction. Apologies, my camera is playing up, everyone, but hopefully my presentation will be ready to roll. So I'm just going to go through a couple of buttons to enable that to happen, and hopefully we will get this up and running now. Can everybody see the presentation there?
We can see benefits of converting straw to energy.
Okay, well that's at the very end. I'll better start at the start, which is where we began in about 2017 with a collective of farmers. Agriculture is a very important sector in the Pyrenees and surrounding shires, and the guys here are harvesting a wheat crop, and the leftover straw is one of the issues that they came to us with, looking for opportunities of what they could do with that excess straw, because at the moment this is a fairly common practice in Western Victoria, particularly in the high rainfall zones where there's such a lot of trash that some of the tools that are available to farmers to do minimum and zero tilling are a little bit complex because the straw just gets bound up within their cropping equipment. And so burning is still one of the tools that's being employed, but our group are looking to develop alternative markets for that straw, and one of them is bioenergy. So in just looking at this next slide, this is a smoke cloud after a 150 hectare crop has, the straw from a 150 hectare crop has been burned, and what we're seeing there is the end result of about 500 tonnes of straw going up in smoke that afternoon. And just to put that into context, the Skipton Hospital project that we're working on for thermal energy will have an annual consumption of around about 400 tonnes. So just skipping along, this is an image of an existing boiler system that was installed in partnership between Pyrenees Shire Council and Beaufort and Skipton Health Systems. So this system's been working at the Beaufort Hospital since 2014. The fuel source for this is about 10 minutes out of town from a local sawmill where they're using wood chips from that operator to provide the thermal energy at the Beaufort Hospital and its hydronic heating system. This is the containerised system that boiler sits within, and it's accessed from the door that you can see at the far end of the container there. There's a viewing window that you can see beneath the chimney, and that viewing window shows people inspecting the wood chips that are contained within the system, how low the supply is getting. And on the left-hand side of the container, you can see where the trucks with the wood chips back into those two gates, and they tip the wood chips into an auger system that conveys the wood chip material into that container to keep it all waterproof and out of the elements. So coming back to our straw group and the farmers, this is pretty conventional stuff to bale up straw, and in the last couple of years they've been fortunate enough to have markets where people in less fortunate circumstances in drought areas have needed materials to feed animals that have been drought affected. But the farming group that we're dealing with are very familiar with systems in Europe where straw is converted to energy in a number of Northern European countries, and they're working with us to try and find solutions in a local context. So during the course of our work with the group, we became aware that Krone in Germany were manufacturing the Krone Primos 5000, which is, as you can see, a tractor-drawn implement that actually makes compacted straw pellets in the field. And so a couple of our group went on a study tour in about August 2018 to visit the Crane factory and to see what this equipment presented as an opportunity for them. And this photo was taken, I think, last summer with it operating on a trial basis in Australia. So this is equipment that's expected to become commercially available in the not too distant future. And this is the end product of straw being compacted into straw pellets, which is the product that we're looking to use at the Skipton Hospital. So the 9 farmers that we're working with crop 14,000 hectares, producing about 50,000 tonnes of straw annually. So there's a large amount of potential for these systems in other locations if we're successful enough in developing the markets for them, and that's what our pilot project at the Skipton Hospital is aiming to do. Throughout the area around Ballarat, which is known as the Central Highlands, it produces about 560,000 tonnes of crop stubble annually, and a little bit further to the west, around the Wimmera Southern Mallee area around Horsham, a further 472,000 tonnes annually. So all in all, west of Ballarat, you can see that around about 1 million tonnes of straw is currently available. Recent figures from Agriculture Victoria indicate that stubble burns in the high rainfall zone, around about 30% of these stubbles are currently being burned. And the Straw Alliance that we're working with are looking at opportunities for proof of concept that it's a resource that can be converted into energy and ultimately eliminate the need for farmers to burn stubbles. So the pilot project evolved for a heat-only system at the Skipton Hospital. The project's been funded and is due for completion by the end of the year. During the early part of the project, we developed a business case for Skipton Hospital, which also looked at combined heat and power options as well. And we're currently looking in conjunction with Ballarat Renewable and Zero Emissions for manufacturing opportunities. And we've also been engaged in conversations with a manufacturer in Ararat to, again, demonstrate proof of concept for straw as a baseload source of energy in a manufacturing context in rural locations. So just coming back to Skipton Hospital, there's an annual spend at the time of the business case of about $55,000 on LPG, and electricity costs $46,000 annually. The business case looked at 2 combined heat and power options, both steam technology and gasification, and then a heat-only thermal system was investigated as well for the hydronic heating and hot water demands at that facility. Straw pellets were chosen ultimately as the fuel source because straw bales were too bulky and provided storage challenges at that facility. So the health services that we're working with chose heat only because it presented a lower risk, lower investment option and the least amount of technological challenges. The project has been funded with the support of the Victorian Government through its Renewable Communities program, and contractors are expected on site in the next few weeks to complete installation and commissioning, with the boiler system currently being conveyed from Europe to Australia. So discussions with the Straw Alliance have been held between the hospital and the farmers to ensure that pellet supply is readily available, and that'll be documented through a contract. The heat-only system is around about a 200 kilowatt capacity boiler system. The business case identified that it would be around about a $265,000 investment, and we allowed for some contingencies which have taken our budget to about $315,000. And our negotiations with the contractors, we feel that we will fit just within that cap for our budget. So the expected annual incomes are the savings in what would otherwise have been invested in LPG supplies of about $56,000 annually. We expect the annual operating costs to be slightly under $5,000 less than that, which at LPG prices of 58 cents when the business case was done gave a fairly long payback period. But depending on where LPG prices end up in the longer term, if we were to consider a 90 cent a litre cost of LPG, then the payback period be significantly reduced to just under 8 years. So annual fuel requirements, slightly under 400 tonnes per annum. We're estimating emissions reductions of about 147 tonnes annually. The Beaufort wood system, for anybody who's seen that, you just cannot see any smoke coming out of the chimney with that system, and if you do, there's something wrong, and it needs to be there needs to be a maintenance intervention. That system is fully automated by a computer system which is monitored by the Beaufort and Skipton Health Services operations team on a daily basis. And in Beaufort's case, they generally empty the ash out every 2 to 3 weeks, and it's only about 3 or 4 kilograms of wood chip ash. With straw fuel, we expect that percentage to be slightly higher, but nothing significantly more onerous. So this is just...
I just want to give you a time reminder.
2 slides to go. This is simply one of the boiler in operation at Beaufort. And the benefits of converting straw to energy are on the final slide, and I'm assuming that and happy for this slide presentation to be shared with the people who are registered today. So rather than running through all that and chewing up time, I'm happy for that to be shared with the group after the event today. I'll now hand over to Dominic Murphy, who's from the Meredith Dairy, for his presentation.
Thanks, Ray. All right, can you see that?
Yes, it is just popping up. By the way, just to say, my goat's cheese on toast this morning was absolutely delicious.
Yeah, it's pretty good, isn't it? So can you see the slide there now?
Sure can. It's looking perfect.
Great. So my name's Dom Murphy from Meredith Dairy. I've got a few slides, so forgive me if I move quickly and talk quickly. I just want to talk about sustainability at the Meredith Dairy business. So just to introduce the dairy, it's a family-owned business run by Julie and Sandy Cameron. And what they do is take milk on a daily basis from our multiple sort of surrounding farms that surround the factory and use that to create sheep and goat dairy products. There's also a significant cropping operation. And across the business, there's a focus of sustainability, so led by the 2 owners, and they have brought on 2 environmental coordinators, one of which is me, who focuses on sort of renewable energy and resources, and another one is my colleague Tim Johnson, who looks more at the sort of farm side of the business and tree planting and things like that. So I'll jump straight in to energy. So across the business, our largest energy demand is at the factory. So that's refrigeration, pumps, processing equipment. And I guess any of these figures are a point in time because I guess demand also always changes, the business grows, and just sort of demand through the year varies. So at the moment, we have electricity demand of about 1.8 to 2.4 megawatt hours per day, and about 2.8 to 3.6 megawatt hours equivalent in heat demand. Now that heat goes to two circuits. One is an 83-degree loop that we call the ring main, which runs pasteurizers, our incubator, and the sort of general heat supply for processes. The other one is a lower temperature circuit, which is for wash down, cleaning, general usage. And at our other sites, so dairies, we have pretty standard loads of pumps, equipment, hot water, refrigeration. So to start with heat, about 5 years ago, they installed a wood-fired boiler. So it's a 240 kilowatt boiler. It runs continuously, and through the bulk of the day, it will output about 150 kilowatts. It heats a tank, which then feeds the ring main circuit. And we feed it with wood chips. So it likes chips at about 20 to 25% moisture content or less. And we currently use recycled chips, 25 mil screened recycled chips, which have a moisture content of about 13%. So really good feedstock and very cheap. We use about 1 to 1.3 tonnes per day of wood chips. And we have LPG boilers which top up through the day, and also as a backup in the event of failure or just machine maintenance. That's the ring main. Our domestic hot water, so this is our lower temperature circuit. We have solar evacuated tubes over the factory. We use about 15 to 25,000 litres a day at 60 degrees. And the idea is that those solar evacuated tubes will sort of preheat the water, and then that's stored and then topped up with heat from the ring main through a plate heat exchanger, which brings it up to that temperature. An issue that we have is that a lot of the time, because we're a dairy and we operate in the early hours of the morning, our usage will outstrip our storage. So we'll have depleted our storage capacity before the sun comes up. So we're currently looking at sort of increasing that storage so that we can extract heat from the sun the day before and store that for when we use it the following day. So our greatest opportunity on either circuits, increasing efficiency obviously, but storage is another really good option, and increasing thermal capacity through heat reclaim or additional bioenergy options, which I'll talk about in a moment. So this is last Tuesday, so a week ago. We've recently secured new suppliers or pricing for both of our fuels, and they're both extremely competitive. So our wood chips are very cheap, and our gas is extremely cheap as well, which doesn't help with the equation. But even considering those points and considering the efficiencies, so the sort of lower efficiency of the wood-fired boiler, we're paying about $7.60 to get 1 gigajoule of energy into our water, which compares to the $23 for 1 gigajoule from LPG. Our current sort of demand, 70% of it is met by the wood-fired boiler, and that 70% costs us about $25,000 a year. By comparison, the remaining 30% coming from LPG is costing us about $32,000 a year, or nearly $33,000 a year. If we are able to completely move away from LPG through things like storing extra hot water, then our wood chips would cost us $36,000 a year to run the factory, including being a very low emissions source of energy. If we had no boiler and we were entirely dependent on LPG, that same energy demand would cost us almost $110,000 a year. So if you look at the graph here, the light blue that sort of is overlaid with the darker blue is our supply from the wood-fired boiler. So it's a general consistent output, and that then charges the tank, which does a really good job of sort of buffering that demand. And you'll see that the sort of highly variable demand from the ring main circuit. So every time we turn a pasteurizer on or turn a process on, there's a significant demand on the ring main circuit. And at points in the day, you'll see this lower line here. Sorry, the figures aren't great, but that's when the steam boilers will come in. So we sense that and sense that the tank is too heavily depleted, so we need to bring the steam boilers on. So electricity, I'll just quickly talk about that. We've installed a lot of solar PV, solar evacuated tubes across our sites, all the things that everybody does to, I guess, reduce their demand. We've still got a bit to go, but we're getting there. And with all of that done, that same day, that last Tuesday last week, this is our interval data for our factory. So you can see that we have a pretty consistent base load, 30 kilowatt hours in half an hour, so a 60 kilowatt demand. And you can see a peak in the morning and a peak in the afternoon, and that's largely attributable to our existing solar sort of cutting into that demand. And also throughout the year, you'll see that we have a bit of a seasonal fluctuation, and that's partly attributable to production, but also attributable to temperature. And another thing to mention is that we purchase LGCs for all of our grid consumed electricity, which means that adds extra costs, so it makes any sort of business case looking at bioenergy even better from that perspective. So I guess that's where we are at the moment. Already saving a lot of money from wood chips and solar, but we want to become completely sort of self-sufficient and look to other options. So one option is obviously thermal storage efficiency. Another one, I guess, there's a lot of talk about solar PV and battery storage to address our electricity demand with just those two technologies. Significant cost and resources. It won't address our heat demand, and we'll continue to have seasonal variation where there's low solar irradiance, but we still need electricity. So another option is to look at anaerobic digestion, given we have a lot of manure, or wood biomass combined heat and power units, given that I guess it's not so daunting to us already having the infrastructure to deal with a lot of wood chips. But both of those, I guess, have practical considerations around how it integrates into our business. So I think a combination, and I'll talk about that, one option we're looking at is really the solution here, not any one technology, but a combination. So again, that Tuesday last week, this is our interval data again. You'll see that demand. We are looking at a 60 kilowatt electrical combined heat and power technology. If we were to implement that, then you can see that would essentially reduce our nighttime consumption to nothing, with the remaining peaks in the afternoon and mornings, with a little bit left in the day. If we also added to that 20 kilowatts of additional solar PV, that eliminates our daytime consumption for the grid from the grid, and we become a net exporter with a small demand in the morning and afternoon, with some ability to add some batteries on there if we want, or shift loads ideally. So I just want to highlight, I guess, that the bulk of that energy reduction is coming from a bioenergy source, like it would come if we go down this path, and the sort of solar PV is really just tweaking around the edges. At other sites where we're not using that much power, we're not really going to invest in a large scale bioenergy technology, but we can look at smaller things. So we have waste oil from the factory, vegetable oil, like the oil that comes in the cheese. So we're seriously looking at some oil heaters for our hot water at the dairies, heat reclaim for the refrigeration of that milk, staged heating, so sort of solar vac tubes to gradually heat up water and reduce the electricity demand. additional solar PV and load shifting. So it really is a combination of sort of understanding our load and trying to do little tweaks to match that energy demand in the lowest impact way possible. And then quickly, just some of the other stuff that we're doing. We've started recycling a lot. We have across the entire business 26 waste streams, and we've reduced our waste to landfill by about 70%, 80% from the factory. We have a tree planting program which Tim's taken care of, which is they've planted almost 6,500 trees this year. Native grassland management, and also looking at composting, manure, and that sort of ties in with the anaerobic digestion option, and also looking at different things around soil tests and soil health, and some other things. So thank you very much.
Can everyone hear me? I think I'm up now, aren't I?
Oh yeah. Sorry, yes, that's, I just want to introduce Ward from Smart Recycle, who's going to present next.
So I'm just turning my camera on now. Does that come up? Can everyone see that presentation now?
No, we can't, Ward. Do you select it with the blue box around it to share?
Okay, I'll try again. That doesn't seem to be working.
Your camera's not showing.
My camera on first. Now I'll try. Okay, is that working now? Does that come up now?
Yes, it's coming up now.
Right. Okay, sorry about that delay. So my name's Ward Petherbridge. I'm the Managing Director of Smart Recycling, and just going to tell you a little bit about our bioenergy boiler for the heat treatment of timber pallets. So we're a recycling business. We've been operating for 23 years. We've got 3 sites around Melbourne. Our largest is in Dandenong. That's a 35-acre site, and we've got a 3-acre site in Epping and another 3-acre site in Brooklyn. And combined, we divert around 50,000 tonnes of waste from landfill per annum. We employ 50 staff, and the Dandenong site, that's actually shared with 3 other companies. So there's about 75 people working on that site. And the waste streams that are recycled at the Dandenong site include builder's waste, garden waste, concrete bricks, soil, and we do a lot of timber waste. So the products we're producing include pallets, crates, boxes, recycled timber, crushed aggregates, blended topsoil, mulch, and compost. I'm just going to try and hide that. So sustainability is at the centre of everything that we do, and we've had a number of sustainable initiatives over the years. We've had a 100 kilowatt solar system for the last 3.5 years, which we did with it as an EUA, which is an environmental upgrade agreement, where you finance the system through the local council. Well, it's actually the funding's through the Sustainable Australia Fund, was originally the Melbourne Sustainable Fund when I did it. And we pay that back through our council rates. So that's actually a really good way of financing solar systems or potentially other energy systems, because it's not against your bank loan book, and it suited us quite well to pay it against our rates. So we've got a 7-year term, so we're about 3.5 years into that. And that system, we didn't have a electricity bill for about 2.5, 3 years, but we've recently built a sort facility which is using a lot more power. So we've actually started shockingly getting power bills again, quite large ones. We've got VSD air compressors with air links. That's no mean feat. With a 35-acre site, we've actually linked the air underground between all of the buildings. Compressed air is a very inefficient form of energy, but it's an essential form of energy when you're running lots of nail guns. We've got LED lighting, over 1 million litres of rainwater storage, solar hot water, sensor lights, double glazing, and we've got 2 wastewater treatment plants. We don't have town sewage, so we have to treat all of our own wastewater. And that grey water is used for watering the trees around our perimeter. So we've got a 20-metre vegetation buffer around the entire 35-acre site. So there's quite a bit of water involved in that. So this image is our pallet recycling facility. That's the solar system on the roof, and behind that, this is taken a few years ago when we were preparing the slab for the sort plant, which was is built right on the corner of the site behind that building. And the bioenergy plant that we're in the middle of constructing is just behind where all those pallets are stacked. So we were the fortunate recipients of the Greater Dandenong Sustainability Award in 2018, and we were finalists last year in the Premier's Sustainability Awards. So timber waste. Victoria generates about 500,000 tonnes per annum, of which 2/3 goes to landfill. That image in the background there, that represents about 3 to 4 weeks of what comes into our Dandenong site. We're getting about 25,000 tonnes in there per annum. And that is collected with a fleet of our own vehicles. We've got 12 of our own trucks that run all over Melbourne, and we use 8 subcontractors. So there's about 20 vehicles crisscrossing Melbourne and parts of regional Victoria. And we collect pallets from building sites. We have various contracts with brick and tile companies where we recycle their pallets, repair them, and they go back to the brick and tile companies. All of that repair work produces a lot of timber waste. And we also collect timber waste from the manufacturing industry, logistics industry. So particularly in the southeast of Melbourne and where we're located in Dandenong South, there's a lot of redistribution, so unpacking of goods, and there's a lot of pallets, crates, boxes in that waste stream. So our primary aim is to actually recycle it in its existing form. That actually makes economic sense as well as environmental sense. The less you have to touch something, the better. But if we can't reuse it in its existing form or repair it or use components of it, we mulch it. So our partners, Ecodynamics, produce landscaping mulch. It's a low value product, and often that market is saturated. It's very seasonal and fickle. When there's big infrastructure projects, we can move a lot of mulch. Large projects that we've supplied from the Dandenong site over the years have included Eastlink, Peninsula Link, the Dingley bypass. The current job that we're supplying is the Mordialloc bypass, which there's about 30,000 cubic metres of mulch going on that job alone, which when you bring it back to volume of timber waste, it's about 5 to 1. So it's about 150,000 cubic metres of raw material, which is around 5,000 truckloads of waste going onto that one job. So we love it when those jobs come along because we basically get rid of all of our stockpiles that tend to build up at certain times of the year, particularly in winter. And we've been looking for an alternative for that low-grade mulch for a long time. There's always a percentage of mulch that isn't as popular with the landscaping project. So if it's got a lot of plywood or chipboard or engineered timbers through it, it doesn't make a very good coloured product, for example. When you colour, so obviously I'm now talking about garden supplies where you can colour the mulch red, black, brown, which is just a food dye. But when you colour, say, plywood, once it delaminates, the raw timber starts showing through again. So it starts to look quite flecky, and the customers complain. So engineered timber is not great for landscaping mulch. So we've been looking for other alternatives for some time. And we looked at animal bedding, and we keep coming back to bioenergy. So bioenergy is simple and straightforward, and we've looked at various alternatives from producing heat to producing power, and we've come back to producing power for producing hot water for the heat treatment of timber pallets. Now, pallet recycling is the core of the Dandenong site. That employs about 3/4 of the people on that site are repairing and making pallets. We build and recycle around 500,000 pallets per annum. If you had asked me 20 years ago when I got into recycling that I was going to become a pallet company, I would have been scratching my head, but that's what's happened. That's how the waste stream has evolved. And again, focusing on reuse, as most of what was coming in was pallets and packaging, focusing on trying to find customers that will use those pallets again and again and again and again, hopefully, that's where we've landed. So a typical pallet sells for between $10 and $15, which is a hell of a lot more than a handful of mulch. And export pallets is a growth area. It's got less competition. You've got to have a heat treatment kiln or to do it, or you can use methyl bromide. Methyl bromide's a toxic gas. Most people use heat treatment, and they're using either natural gas or LPG to heat their kilns. Now, we've got a plentiful supply of timber waste, and we also receive a tipping fee for that timber waste. So we've got a valuable revenue stream for that material. So the economics of our project are very much linked in with getting that tipping fee. It wouldn't be viable for us to do this project without that. A gas boiler would have been a fraction of the cost of what we're spending on this. This is a $2.5 million project. Yeah, it would have been a lot more simple to do the gas boiler, but we don't actually have a mains gas connection, so I would have been relying on LPG. And I also have the ethos that we want to use everything that comes into the site. So anything that comes in needs to be recycled. So even the ash from this boiler, we're hoping to get EPA approval to blend that with our crushed aggregate. Any nails in the ash will be taken out with a magnet, so nothing will go to waste. So in January 2020, we were awarded a Sustainability Victoria grant for $437,500. We're building a 2 megawatt hot water boiler. That's under construction in Italy. They're about halfway through that at the moment. We've got 2 pallet heat treatment kilns under construction in Melbourne. We're going to heat water to 85 degrees to supply hydronic radiators for the kilns. And each kiln's capable of heat treating 600 pallets per cycle. Now, for an export pallet to be certified, it's got to be heat treated to ISPM 15 standard, which is the international standard for phytosanitary measures. And that requires 56-degree core temperature for 30 minutes. So that means the thickest part of the timber, you have to actually drill into it, put a temperature probe in, and you've got those probes all through the kiln. So that the inner timber of that pallet needs to get 56 degrees for it to meet the requirement. And then you can stamp it with an IPPC stamp and it's ready for export. And obviously that prevents the spread of disease, kills any insects that could negatively affect plants or ecosystems overseas. So fuel for the boiler will be waste timber consisting of wood chip, which is made from pallets, crates, boxes. We're looking at using about 2,500 tonnes per annum, which is a fraction of the 25,000 tonnes we get in each year. And there's a bag house and cyclonic filter to clean up the flue gas to EU standards. We didn't necessarily have to put that in, but we wanted to basically put our best foot forward and do world best practice. So the boiler we're using is a Uni Comfort Boiler from Italy. And in the background there, you've got some images of the typical sort of packaged material that we're utilising. You can see there's a fair bit of plywood. So it'll be plywood, chipboard, MDF, oriented strand board, pine, hardwood. It's a real mix, probably about 50% engineered, 50% non-engineered. That'll be shredded through one of our mulching machines to be around 10 to 20 centimetres in size. Here's some more images of the boiler. Again, just to give you a sense of scale, it's not huge. You've got a person standing next to a similar boiler there. The boiler house is about 12 by 12 metres. The stack, 12 by 12 metres. The stack's about 12 metres high. We've got a 40-foot shipping container, feeding bunker, which augers the fuel into the boiler. Some more images of the Uni Comfort Boiler there. And this is an image of the kilns. So this kiln in that image would hold about 600 pallets. So we'll have 2 of those side by side. So the reason being we can have one kiln being loaded or offloaded while the other one's cooking. So we can always have one operational. And above that is the image of the IPPC stamp. So you can see that you've got the tree symbol there. That's the international symbol that pallet or crate or box has been heat treated. It'll have HT for heat treatment or MB for methyl bromide. It's got the country of origin. So in our case, we'll get our own stamp, which will have AU. And then that code specifies the actual facility So you can look at any pallet anywhere in the world, and you can actually trace it back to where it was manufactured and where it was heat treated. So each batch will take about 4 to 5 hours to reach the core temperature. That'll depend on the time of the year. And as the fuel's cost neutral, for us, longer residence times will be economical. So I'm looking at actually doing contract heat treatment for other pallet crate box manufacturers. There's not many in the industry that will do that for their competitors. I'll be doing it for anybody who wants to knock on the door. And we can offer those longer residence times that people burning gas or LPG, it's just not economical for them to do that. So we can take larger items, they can sit in that kiln for a day, 2 days. That's not a problem for us.
Sorry to interrupt, Ward, we're just reaching time.
Excellent, because I'm just about to finish. So that's another view of our pallet recycling facility. You can actually see a mural that we did last year with a group of local artists. Again, the recycling pyramid is there in the background: reduce, reuse, recycle. So recover is there above landfill. Obviously, our aim is reuse, but there's just some materials like these low-grade mulches that I think the best use is the recovery of energy, and we're doing that. So as you can see, construction's commenced, and we've got the conduits in the ground. We've got the footings have been poured for the boiler house, which is going up this month. Kilns will go up between now and Christmas, and the boiler should be arriving from Italy in the new year. So we're hoping to be up and running about April, May next year. And there's my son in the foreground there with his Tigers cap on, so go Tigers. Thank you very much for listening. And I believe questions are going to be at the end. So I'm just going to try to get out of here and stop presenting. How do I do that? So stop sharing, and I am going to hand over to Robert from Fru Foods. So have I stopped sharing my screen now?
Yes, you have.
Great, thank you.
Hello, can everybody hear me?
Can do.
Yes, we can.
Can I just make a reminder for everyone who still has their videos on to turn off their videos, other than obviously the presenters, so that we can make sure we're limiting distractions.
Yeah, you should be able to see that. Yeah.
That's perfect. Robert?
Yeah, no worries. So I'm Robert Frew, Managing Director of Frew Foods International. We're a lamb processing facility in Stawell, Victoria. We employ 500 staff, and we process about 30,000 lambs a week. Now, the reason why we sort of got into this bioenergy system is because biomass system is because we were pretty much a huge cost in our business is gas, electricity, and water usage. So we sort of 5 years ago did an audit on our plant just to see where we could possibly take some cost out of our business, and we realised that some of the projects were a bit expensive for what we were going to get back, but as time went by, gas and electricity prices got very, very expensive. So we thought, well, we need to do something fairly quickly. So we invested in solar and biomass for our gas to heat our hot water. So basically, we use a product which is just pine sawdust, recyclable sawdust, and we bring that out of South Australia. So the particle size is quite small. The moisture content can be up to about 50%. So we run about 30 to 50% moisture content. That depends on the time of the year, whether or not it gets damper during winter time. But our system's been adjusted so we can actually burn the product fairly efficiently, depending whether it's 30 or 50%. We just change the parameters of the system, slow down the burning, and we end up with the same result. So for us, it's a cheap product. We backload that product on our own vehicles back to our holding facility where we built a large shed to store the wood chips or the sawdust. Basically, we burn about 60 tonne of the product a week, and so we're basically running 5 days a week at the moment. We ramp and slow up the production as we need to get the hot water for what we need during the day, and then we ramp it up for cleaning down where we use the majority of the water, and then we slow the system down again and fire it back up a lot earlier in the morning, get ready for production again. So for us, we're running at 3 loads a week at the moment. When we get busy, we'll probably go to 5 loads. The system we've put in is a 3 megawatt hot water system. So we also have a small system where we can also create some steam. As well, but this system here is a floor. Our trucks tip the product back on the floor, and this pulls the product into the system. We backload the product from South Australia, which makes it very viable for us because the transport costs are quite high. If you had to get it delivered in, it's very expensive. So we backload the product back in from South Australia, so it's quite cheap for us to do that. We burn around about 500 kilos an hour on the system. It can burn up to 1,400 kilos an hour, but we don't need to run it at that speed. We can create enough hot water over the day to do what we do. So we're basically only running the system at about 50% of what its capacity is. So we've got plenty of room to expand the site and even absorb more cost savings as we go forward. So these slides. So that's the inward thing. That's our trucks bringing back the material that unload onto the moving floor, which the system's fully automated, so we don't need anybody in there to manage it. It's just a matter of keeping an eye on the system as we go along, and we've got people within the facility just stick their nose in to make sure everything's running correctly. But it's fairly straightforward, and we haven't had too many issues up to this stage. The system was installed in February this year, so once we've sort of run 12 months, we'll sort of have a bit more of an understanding of any wear and tear on the equipment, but I don't think it looks like there's too many things that are going wrong. This is the actual unit and the actual room that it's in. So the actual room that we put it in is 30 metres by 15 metres, so it's 450 square metres. We've had to put a bit of an extension on the front to keep the raw material dry, because we were having issues with over moisture product, which was a bit of a problem for us. So it wasn't burning correctly, and we had to continue to change the speed of the system, which we've fixed that all now. Everything's enclosed within the shed. That's the control panel. So basically, it can be controlled from anywhere in the world. Obviously, just linking into it, and but we pretty much have control of it ourselves now. It runs fairly efficiently, so there's not too many things we have to modify or do on a daily basis. We're only burning the one material, so it's fairly straightforward. So it's all set up to do that. So if we're burning different materials, we'd probably have a lot more issues. So it's a lot easier just burning the one sustainable sawdust product that we get out of South Australia, which is, as I said, very efficient and cost. So that's the front of the shed. So we've got the large water tank there. And that's the unloading area where the B-double can basically, each trailer can be tipped up to its full height. So all the product falls out of it, so we don't have to worry too much about unloading the trucks. It's fairly straightforward. And then we have the buffer next door. We can hold up to 200 tonne of product in the shed if we need to. About 60 tonne on that movable floor, and about 140 tonne next door to that, through the Christmas periods and that sort of where we get the raw material for them if they have a breakdown or a shutdown for any period of time. So the burning rate is very good of the product. So we basically don't get a lot of ash at the end of it. It's 0.5%. So basically, we only sort of get about 15 tonne of soot a year. This picture here shows the different heat exchange systems we've got. So we run the different temperature to different parts of the factory. So we have cooking processes which require 92 degrees water. We also have obviously wash down water for the showers, for the hand basins, the sterilizers. So we've got about 4 or 5 different temperatures that we run. And all of that is basically just finished through the heat exchangers to get it to the temperature we need to get it to. And also that's very efficient and it's instant. So it's a ring line system. So the water keeps coming back to the tank. So we basically always got the right temperature through the plant, which used to be a real issue for us before when we were running boilers and trying to adjust the temperature. This system's a lot more efficient and a hell of a lot cheaper to run. So this is an outside shot of the actual overhead gantries that carry all the water. So it's approximately about 200 metres long and about 5 metres high. We built it well away from the plant because we've got, in the future, we will be upgrading the plant in certain areas. So we just wanted to make sure that we didn't have the issue of having to move the pipework. So for us, it was a bit more costly to do it this way. Probably cost us an extra $200,000 to do it, but it's well worth the effort of moving it away from the plant. And we've got down in the future, we're looking to put in a rendering plant on site as well, which will be fairly close to this biomass system that we've put in. So for us, it's all about thinking to the future. The payback on this system is probably 3 or 4 years. But as we get busier, the payback will be higher. When we first looked at putting the system in, our gas, to give you an idea, our gas bills had gone to $60,000 a month. They're back to about 40. Since we've put this system in now, they're at $4,000 a month. So there's a 90% saving, and then on top of that, you've obviously got to add the wood chips back in, the freight. So we're probably running at about 75% of our normal cost. So for us, we're probably saving with the system, the sawdust and the freight, less labour costs, less maintenance costs, probably close to about $470,000 a year on this gas system. So on this biomass system to reduce gas usage and burn wood chips, so or sawdust. So for us, it's a huge saving. The actual raw material we get out of it in the end is just some soot, which, as I said, it's about 15 tonne a year, which we just blend in with our manure, animal manure, and land spread after about 12 months once the manure is broken down. And we've just killed all the weeds and stuff that you get in animal manure. So that's basically the system. The reason we put the system in, as I said, was to obviously take cost out of our business. We had no control over gas prices. We had no control over electricity prices, and we've also put in over 5,000 solar panels now, and that will start up. The final commissioning of our solar panels is the next couple of weeks, and that will take 70% of the cost out of our solar, out of electricity costs, which again is probably another $700,000 a year saving for the site. So because we are a large processing facility, our utility costs are very, very high. Water's similar, very expensive to buy in, a lot more expensive to discharge. So we've built a lot of large dams to combat that, so we can break down the BODs in the water to a point where we can now irrigate and grow crops as well. So that's also been a big plus for us as well in reducing our greenhouse gas emissions by reusing water, growing crops. It's been a big plus for us. The system doesn't give off any odour, obviously, because we're burning pine chips, so that was another plus. No odours, and we've got a 10-year contract on the raw material coming in. So we'll probably start looking in 3 or 4 years' time for more, looking at more products that maybe we can put through the system. The system at the moment is set up for what we're doing, but I'm sure if we've all listening to some of the raw materials that are being used today in some of these systems, I'm sure that we could source some of that product and backload it if we did have an issue with supply of sawdust. So all up, I think moving forward, our maintenance costs look like they're going to be a hell of a lot cheaper. Our original gas boiler system that we had a 400 kilowatt gas boiler system plus a 200 and 100, and they were fairly quite old pieces of equipment. For us to have revamped that system would have cost us over $1 million, and this system's probably cost us a bit over $2 million to install, plus a shed and plus a few bits and pieces. So it's very, very cost efficient for us. We believe that it'll last, it'll give us scope for the next 25 years to expand the business. We could double the size of the business with this system. So we've got plenty scope to expand. And that's basically my presentation. So I don't know how long I've taken. I've sort of lost a bit of track of time. But so if I'll hand over to Sandy Gray, Technical Director of Gaia Envirotech.
Very good. Thank you for that. Great presentation, Robert. Fantastic exercise. I hope everyone can hear me now.
Certainly can. Yes, we can.
Okay, here we go. I'm sharing my screen. Hopefully you should be able to see my screen. Can you see that?
Yes, we can, Sandy.
Okay. All right, very good. The start of the program, I guess, firstly, I'd like to say that it's great to see all these other projects happening. I guess the thing that we're trying to do at Gaia is to bring some of that technology to homegrown technology. A lot of it appears to be coming from overseas. And so we're trying to bring some of that back on shore and make things happen here in Australia. Can someone just tell me, did that just change slides then?
Yes, it did.
Okay. So we've got a multi-stage anaerobic digester. I'm going to flick through these first few slides reasonably quickly just to give you a feel for the technology. Basically, we're breaking down food waste, byproducts from animal manure, whatever we could get our hands on. We obviously are converting that then into either heat, electricity, and more importantly, looking at the whole system and how we can obviously maximise the products, but also looking at what else we can do in the system at the same time to handle waste streams in general. So the benefits to the users is that obviously it's an environmentally friendly waste disposal system. It reduces odour and organic loadings. We're destroying potent greenhouse gases. We're looking to produce chemical-free fertilisers from the discharge. And of course, very importantly, we do on-demand renewable energy. We can store our energy for use in the peak periods. And as you saw with Dominic's chart, those peaks are still an issue for a lot of renewable energy outcomes. So also green credentials for producers and supply chains. So this is value generation. Effectively what we're doing is we're taking feedstocks. We're looking at what I'll talk about in a minute is blending feedstocks and how we understand that better. Obviously carbon credits, fertiliser for use on the farm, energy, all of those things. I'm sort of probably preaching to the converted a little bit in this. I guess the modular design, the really important part of this is that the system is easily expandable. So we can start with a smaller system. We can expand it. We don't have to build in the final expanded finished unit or capability for expansion later on. We can actually build in a smaller unit and keep increasing it. We just keep adding cells. You can see the multiple cells we're using in this system. And importantly, the actual process of biodigestion really requires different pH levels and different chemistry at different parts of the process. So the first part, which is hydrolysis, requires a lower pH, and then you have a slowly climbing pH. So having a multi-stage digester makes a lot of sense in the system. It's much more important to try and optimise the efficiency. And you can see in some of the previous presentations that efficiency and ability to achieve paybacks, reasonable paybacks, really relies on us getting the efficiency up on these systems. We don't have, in a lot of cases, the same benefits that other people have, for instance, in Europe, where they have very small land holdings. There's much more emphasis on reduction of waste and doing that in a much more, much smaller land area. We have much greater land mass, so that makes us a little bit more lazy in this area. So that's where we really need to be more efficient than most.
Sorry to interrupt just quickly, Sandy, but could all of the attendees please turn their cameras off? If you've got your camera on, it's very distracting for people trying to listen to Sandy and watch the presentation. Thank you.
So importantly, the system is fully automated, and obviously we've sought to make it as hands-free as possible. We can obviously look after it, manage it from back at head office in Gecko, and we require some physical checking just to make sure that things are working properly, or that we don't have spillage or whatever might be. But generally, the machinery looks after itself and only requires relatively infrequent maintenance. So waste management solutions, what I'd like to talk to you about is the fact that what we're really trying to do is, and I think in Dominic's presentation it was really interesting, because what they're looking at is a whole raft of solutions, not just one solution to solve all of their problems. So in our case, what we're looking at is how can we connect this system that we're using at the moment into other systems to benefit those systems. So things like, for instance, our fibre coming from the system might be composted to go back for animal bedding. In one case, we're looking at recycling the bedding, which is a gravel product, recycling that gravel through from our mining experience, being able to utilise that to recycle their gravel back onto their systems, into their beds, and looking at post-treatment for water, for recycling water, and obviously for making it more available for respreading back onto pastures and other agricultural outcomes. So really try to manage the whole solution system is important for us. So we've so far run a pilot on a 300 cow dairy. It's an undercover dairy. We collect 24,000 litres a day of manure. That's our feedstock. We turn it into biogas, and then the biogas goes to power and whatever else. Soil conditioning from the fibre that's produced out of that material, and one of the potentials is to turn that fibre into bedding and put it back into the barns again. We're working with the government, with FIAL, Food Innovation Australia, at the moment. We've got a program running with some of our sponsors, like TasGas, major sponsor of this program, Meredith Dairy, Trigg Farm, Trigg Dairy, Booth Transport, and ourselves, obviously. We've just installed a pilot, and I'll talk about that in a moment. But what we're really looking at is the mixtures of feedstocks, and how do we utilise those most efficiently. And for instance, you might want to join a low-grade feedstock and a high-grade feedstock together to give you the best efficiency and optimise the outcome of the system. So one of the things that we've been working on is building our own biodigester or biodigestion lab. This we feel is the most important. The first question we get asked by all of our clients and potential users is what can we get from our waste, and what's it going to look like? How much is it going to cost? And what's the final program at the end of the day? We really can't answer those specific questions very well without doing work on the actual feedstocks. And we didn't find anywhere in Australia where we could really get the answers to those questions down to the detail that we needed. So we're able to look at the feedstocks, carry out digestion on them, and understand what sort of outcomes that we can get. So we're looking at making that scalable into the full-scale commercial units. This is just a picture of some of the work. So you would think that cheese whey and permeate might not be very different, but feeding into the same system, you can see that the permeate responded extremely quickly, but then it looked like we had an overfeeding event, which meant we had to slow it down. And then, of course, we came back to about the same point as the cheese whey. It just shows you that, intuitively we would have thought that cheese whey and permeate might be relatively similar, but obviously needed to be treated differently. So the right-hand bottom corner, you can see some of the work we're doing on clarifying some of the water or the low density feeds we're getting, and looking at this as a pre-treatment ahead of the treatment. We can do that work in our laboratory at the moment. It's very important to be able to upgrade and take out the COD, BOD materials into a more dense product that we can feed to the system to get the efficiency up and get the capital costs down. So the demonstration plant, a very large cheese manufacturer in Southern Australia. It's an 8-month deployment. It's been held up quite a lot by COVID, obviously. Food manufacturers got very concerned, obviously, about COVID, and we've not been able to access the site since the beginning of the COVID thing. We were literally 2 days from turning it on. We'd put the bugs in and had to walk away. So we're about to get back on site now and start the pilot, which is very exciting. We're doing both cheese whey and milk permeate on the same site. And this will give us fantastic data for what is a very large industry dealing with those products at the moment. And a lot of what's driving that is obviously the disposal of those products is getting more and more difficult for people. So assessing the biogas production and downstream water disposal issues are all driving these things. So that's a pretty exciting project. I guess the next one is we're about to start site construction this week in Northern Victoria for a company who are bringing in waste, high-value waste from all over Victoria, actually, and into New South Wales. And we will be building our new digester. We've just shipped it out of the site here at Gecko, and it'll be being constructed and commissioned over the next month or so. Very exciting project, and already talking about expansion because the availability of obviously waste from around these parts of the world is growing, and people are really looking at doing things with their waste to add value. Then I guess we've got advanced negotiations and an MOU with another food manufacturing company working in Western Victoria. At the moment, we're doing continuing trials with those guys, looking at how we can best supply energy to them, and that would be probably combined heat and energy. It'll probably be, the great thing about this one is that we can provide relatively low-grade heat, which is usable in their process, right through to high temperature heat and potentially power through the fence. And we'll be looking at potentially doing this one as a we would provide the equipment, and basically they'd provide us the feedstock. We'd provide the energy back through the fence to those guys. So we've got a bunch of other food manufacturers and growers that we're talking to at the moment. We've got a lot of work that we've been doing in quoting. We've got a lot. Our lab is flat out at the moment, reviewing different waste streams, and it's a very exciting time. So I think pretty much that sums up where we're up to. And of course, there's a lot going on in this space. It's very exciting to be part of it, and certainly we'd love to be trying to reduce the amount of technology that's coming in from overseas, and be producing it in Australia locally for our local market. And that's probably all from me. So thank you very much for your time, and I'm going to hand back to Andrew, I believe.
Thanks, Sandy, and thanks to all these presenters. Just a terrific group. And Brendan Mason and Patricia Nesbitt and John Lawrence, if I can get you to turn your videos off. Thanks. There's a whole list of things. I've been keeping tabs on the chat function, and there's been a whole lot of questions coming up. But each time, frustratingly, they get answered by whoever it is. But Sandy, some of the ones, just Sandy Gray, coming to you first. Some of the questions have been about things like, can you turn straw into biogas as a preferential approach? And have you looked at this? Straw's difficult because it tends to sort of become a cake on the top of the layer, and if you're not stirring it like some of these other fibrous things, you have a problem. Maybe cow manure might be another one in that category. Have you looked at this as a possible feedstock?
So we're doing some work at the moment, but more, I think that these very fibrous materials, as you say, are quite hard to manage in a biodigester. And in fact, what we typically would do would be, what I'm interested in looking at is, can we extract anything, pre-extract any energy from it ahead of taking it out, and then probably more likely to use it as a composting type material, or potentially, as we've seen today, to potentially burn it, I suppose, if we could get the moisture levels down in it low enough. But typically, these very fibrous type materials are not as exciting as, say, factory food waste, where you've got very high energy levels. And obviously, lower energy waste is not as attractive because of the time, the residence time required, and the very large storage facilities you need to actually get the digestion happening. So we're looking really for a start to try to get to the very highest energy materials to get ourselves started, and then maybe look at what's possible down the track later with the lower energy.
And I'll ask another question too, just because it's an interesting one with abattoir wastes and the other residues from food processing that might be equivalent. How does the capital cost and return on investment stack up between your sort of system and the more conventional above ground insulated tank and reactor tank and storage system?
Yeah, so look, I would say, and we've not done recently a very direct comparison. They're very, as I said, we're really providing systems for these outcomes, and so they're very the actual costing, the capital costing, but typically we need to be paid for all the streams. If we're not getting gate fee in, we need to be paid for everything, including fibre, energy, gas production. We need to be getting more than just gas price for behind the meter gas price to make these systems work cost effectively. But then there's a lot of other things that come into play. For instance, odour is a big one, and you mentioned waste from abattoirs. Digesting paunch, for instance, looks like being quite a viable outcome, and some of their wastewater streams, I believe, will be worthwhile into the future. But it is difficult to say. We believe that with the efficiency of the multi-stage digester, that we will be capital cost effective over and above the sort of single big tank type systems.
Fair enough. Just one more question for probably Robert Frew and Ward Petherbridge, perhaps. There have been a couple of questions put up in the chat column about the use of organic Rankine cycle for these little turbine generator systems using an organic gas that can gas liquid transition that can work on either waste heat or as an initial, and it might also apply to Sandy Cameron, Dominic Murphy, just taking that initial high temperature heat out of a furnace, turning it into power, and then using the lower side of the heat to go into your heating loop. Have you looked at that? Is that relevant?
We have looked at it, and they are quite expensive systems. So certainly for phase one of our project, we've ruled it out. But yeah, we are interested in pursuing that perhaps in the future.
I might send to you something that's come out of Sweden. There's a Swedish-made organic Rankine cycle that might be getting it down in price. Robert, in your system, have you looked at either organic Rankine cycle or anaerobic digestion to produce some of your power?
Yeah, we not into power. We were turning our organic matter into pellets, basically as fertilizer. But that was with another company from Singapore. But it never we did it for about 18 months, and then they had issues with marketing the product into the market, so that stopped. And hence we built the biomass system to burn the sawdust. We only create, we don't create a lot of, well, obviously we've got punch manure, but we don't have enough of it to make it viable. Probably more of a beef, large beef processing facility or something like that, but we just don't get enough of that good material to make it work. And it is quite an expensive system to set up as well to capture that gas and then be able to polish that and clean it to use back into your plant. So I think for us, because we're on a large property, we've got 800 acres here. For us, it's a lot easier to just to turn the manure over, break it down over a period of time, and land spread it, and utilise that to grow crops more so than try to turn it into a gas product. Yeah.
Another one for Sandy Gray from Robert in the chat column. What's the treatment capacity year or tonne per day, or maybe wet cubic metres as a unit of the containerised system?
So obviously we can do very small units down to a tonne or two, half a tonne a day type system, and up to, I would say at the moment we're probably limited around 100 tonnes a day, 50 tonnes a day type systems would be.
Sorry,
really.
can I just interrupt a little bit? Robert, do you mind just popping your mic on mute? I think we're getting a little bit of feedback.
Right, yeah.
Sorry, can you hear me now, Shahana?
Yes, that's perfect.
Yeah. Okay. So yeah, look, very small systems, maybe half a ton a day type stuff, or hundreds of kilos a day, up to sort of 50, maybe 100 tons a day type of systems. We're really looking at where's the break point, at what stage does it just become too large for us. And a lot of these systems, they sort of might have a lot of waste, but they don't actually need as much energy as we might produce. So we're looking at what's the energy break point as well. Where do we satisfy their energy requirements, or at least do as much as we need to get them out of trouble. So it's a bit of a balancing point at the moment.
Thanks for that. And Dominic Murphy, if you're still there, the Meredith dairy with a lot of livestock, a lot of bedding, maybe quite a lot of byproduct. Have you been looking, has the company been looking at anaerobic digestion as a source of heat and power?
Yeah, we have. We've actually got some whey and permeate being tested at the moment, along with manure. One challenge that we have is just the period of time that some of the manure is kept in the sheds. So a lot of by the time it's cleared out, it's a lot of the potential energy is gone from it. So we're actually in discussions with with somebody who's on the line now, just around trying to get some testing done for that and give us some potential yield.
Okay, thanks. In the chat column also, there have been a number of points to where testing has been done, and I know there are at least 2 or 3 available testing organisations, and so that's obviously a key thing to do, so everyone knows what the potential is. Now, I'm going to wind up here. Again, Victorian Bioenergy Network is looking for new members to build ourselves back up to the sort of mailing list of something like 400 to 600 that they had at the peak activity period, maybe 2015, 2016, across government departments, biomass producers, technology, original equipment suppliers, et cetera, industry. And the potential is fantastic, particularly for the sort of people we've been hearing today, where there is a need for industry heat. Price of natural gas has tripled, price of power has doubled in the last 5 years, and this is the solution. There is 1 million tonnes of straw available, not that that's the primary sort of choice for a lot of people. There's probably millions of tonnes of wood chip available at a price of something like $6-7 a gigajoule delivered. So the opportunity is fantastic, and we can only go upwards and onwards. So thank you very much for all being part of this. Shahana, do you have another final sort of thing to put in?
Yeah, thank you. And I just wanted to thank Andrew and Kelly and the team and all of the presenters today, as well as Lauren from our team. Putting in a plug for Bioenergy Australia as well. Anyone who's interested in participating in things such as the Renewable Gas Alliance, our Heat and Power Committee, Circular Economy Network, or our Cleaner Fuels Alliance, we would love to have you involved in that. Obviously, our agenda is very much around seeking advocacy outcomes that are going to support the development of the industry, but also driving commercial outcomes within the sector through enabling connections and the like. So if anyone needs a hand with anything, please just get in touch with us as well. Happy to support. And I think Andrew has just popped up, or Kelly has just popped up Andrew's email address again in the chat feature. And we will make sure that we send out those details to enrol for membership of the VBN as well in our follow-up email, with a link to the presentations. That will come out in about 24 hours. It takes about that long for the session to download. So once again, thank you everyone for participating, and well done, Andrew, with keeping it all to time. You were really nervous about it, but I think it's actually the first one that is finishing on time. So well done.
Oh yeah, look, we're high achievers generally, and the other thing is Victorian Bioenergy Network. We're working on particularly Daryl Sherger, our secretary, working on getting our website back up. That should be happening in a month or so, hopefully at the fastest, and it will be carrying case studies. It'll be carrying all sorts of other detail, and we'll gradually get a register of sources of information of every sort that are sort of semi-reputable and recommended. So thank you very much. That's it, guys and ladies, and until next time.
Thanks,
Goodbye.
Shauna.
Thank you.
Thanks, Andrew. Well done, Ward. Thanks, guys. Be
Very
good.
good. Thanks, guys.
Peace.